Hello everyone, welcome to today's video. So in this today's video we'll be solving the problem minimum number of operations to make array continuous. So this is the problem of the day that's being asked on LeetCode, and it's a hard level question. So let us first understand the question. You are given an integer array nums. In one operation you can replace any element in nums with any integer. Alright, and nums is considered continuous if both of the following conditions are fulfilled. All elements in the nums are unique, and the difference between the maximum element and the minimum element in nums equals nums.length minus 1. Alright, so nums.length, it's the size of the array minus 1, and that must be the difference between the maximum element in the array and the minimum element in the array. For example, nums is equal to 4253 is continuous, but nums equal to 12356 is not continuous. Why is the first one continuous? Because the minimum element in this first nums is 2 and the maximum element is 4, and the difference between both of them is 2. The maximum element is 5. So the difference between both of them, that is 5 minus 2, is equal to 3, and that is nothing but nums dot size, that is 4 minus 1, which is equal to 3. And also the elements in the nums are unique. But whereas coming to the second example, the maximum element is 6 and the minimum element is 1, where the difference between these two is equal to 5, which is not equal to 5 minus 1, which is equal to 4. Alright, 5 not equal to 4. So nums dot size minus 1 gives the result as 4, whereas the difference between the maximum and the minimum element came up to 5. So it's not equal, and that is the reason it's not continuous. So written the minimum number of operations to make nums continuous. So that is the question. So we'll understand the approach first, and then we'll see what could be the better approach to frame the code. So let us go into the examples first. So the very first example, 4253. So once we sort this, we get 2, 3, 4, 5, right? And the minimum element is 2, the maximum element is 5. So the difference here that's coming out to be 5 minus 2, which is equal to 3, and that is actually equal to nums dot size, that is 4 minus 1, which is equal to 3. So both of them are equal, so it's fine. So there is no need of any operation, and that is the reason the answer is 0 in this case. But coming to the second example, so 1, 2, 3, 5, 6. All right, 1, 2, 3, 5, 6, and it's already been sorted, so no need to sort. So this is the minimum element, this is the maximum element. The difference comes up to be 6 minus 1, which is equal to 5. And the actual difference that they want to be there, that is equal to nums dot size minus 1, that is 5 minus 1, which is equal to 4. And these two are not equal, and so that is the reason we need to change a particular element, right? We need to change some or the other element so that we end up with the difference equals to 4. All right, we end up with the difference equals to 4. So what could be that change? That is what we need to identify. Basically, we just need to return the number of changes, but it's also important that we understand like what are we actually trying to change. So let us get into deep with this example itself. With the help of this example itself, let us consider the one, okay, the very first element, and it is the minimum. Let us consider it is the minimum element that we are trying to find. So minimum element is equal to 1. And what could be the maximum element if minimum is equal to 1? So like as per the question, we just need to want the difference between them, both of them, to be nums dot size minus 1. So the minimum element, if I'm considering it as 1, what could be the maximum element? That should be 1 plus 5 minus 1, which is equal to 5. All right, so maximum element that can be possible is 1 plus 5 minus 1, because this is the difference they expected for us to have between the maximum and the minimum element. So if my minimum element is 1, then the maximum element could be the 5. Okay, could be 5. So, and because this array is sorted, all the numbers or the elements to the right side of the 5. So do we have 5 here? Yes, we have 5. So all the elements to the right of 5, need to be changed. For sure. Why is the reason? Because 1, 2, 3, 5, they're actually satisfying the required condition, because 1, 2, 3, 5, these are already unique, and the minimum element that we are on is 1, and we are trying to find the maximum element, that is 5. Yes, we have got 5. Now to the elements that are right of the 5, all those should be changed, right? All those should be changed, nor the maximum will go up, will be more than 5, which is we like maximum will be more than 4, right? Maximum will be more than 4, and we do not want that. All right, we do not want that. So we need to change the elements that are right to the 5. So what are the number of elements that are right side to the 5? Only one. So we need one operation. All right, we need one operation. If in the case we are considering 1 as the minimum most element, okay, if it's a case, if we are considering 1 as the minimum most element. Now let us take second case. Okay, so this is a case, let me write it properly. So the very first case that we have taken is, okay, so I'll even erase the first example that we have taken. I'll just mention this array first, and we'll go into the deeper insights. So the nums is equal to 1, 2, 3, 5, 6. Okay, consider the case 1. Case 1 is when 1 is the minimum. Okay, minimum equal to 1, and if that is the case, the maximum can be 1 plus the size. What is the size? 5. So 5 minus 1, which is equal to 1 plus 4, that is equal to 5. All right, 1 plus 1 4 equal to 5. So minimum is this. Minimum is this is what we are considering, and maximum is this. So all the elements that are right to the 5 must be changed. So how many are there? Only one element. So in this case, the answer is equal to 1, right? In this case, answer equal to 1. Coming to the second case, case 2. Case 2, what if I consider the minimum element to be 2? All right, if I am considering that my minimum element would be 2, in that case, the maximum element that can be is 2 plus 5 minus 1, which is equal to 6. All right, and that comes out to be this one. So, and there are no elements to the right of 6. There are no elements to the right of 6, but there is an element to the left of 2, right? There is an element to the left of 2. So we need to change this element. We need to change this element so that my particular nums has got the difference between the maximum and the minimum element to be 4. Okay, that is the thing. So in this case, in case 2, we need to change this particular element. So again, in this case, answer equal to 1. So let us erase these things for better clarity. And yeah, so this is the case. What if case 3? In case 3, I am considering the minimum element to be 3. In that case, my maximum could be 3 plus 5 minus 1, which is actually equal to 7, right? 3 plus 5 minus 1 equal to 7. So what are the minimum elements that like this is the minimum element that I'm considering, and there is only maximum possible is 6. All right, so 3, 5, 6 can be part of my array, but 2 and 1 cannot be a part of my array, right? 2 and 1 cannot be a part of my array because the minimum possible that I'm taking is 3, and the maximum that I'm taking that can go up to is 7, and I have only these 3 elements which can be a part of my array, and these 2 cannot be a part. So in this case, my answer equal to 2 because I need to do 2 operations. So similarly, so I'll just erase this case. I hope you people understood what are we trying to do. So we are trying to figure out all the possible cases, all the possible minimum things. So what if I consider this as the minimum, this as the minimum, this as the minimum, this as the minimum, this as the minimum. So I'm considering all the elements to be minimum, and in what case are we having the less number of operations to do. So that would be the best case. So consider case 4. Okay, case 4, in which I'll be taking the minimum element to be 5. In that case, the maximum that it can go up to is 5 plus 5 minus 1, which is equal to 8. And in that case, we have only this element and this element. So these 3 must be changed. All right. So the answer would be equal to 3. Similarly, case 5, we can go up with the case 5, and we can find out what if I'll assume minimum to be the 6, and then maximum can go up to 6 plus 5 minus 1, which is actually equal to 9. So in that case, I cannot have these 3 elements. These 4 elements, to be honest. So only this element I can have, and these 4 must be changed. So in that case, my answer equal to 4. So I need to do 4 operations in that case. So what's the best case? Either I can go with this or this, because in only these 2 cases, my number of operations is very minimum, that is actually 1. So I just need to do 1 operation in both these cases. So this is the approach. So the approach is simple. First, try to like the very first thing, the other first thing that we need to do is, because this array has been already sorted, so and all the elements are unique, we did not check for the other condition. What is the main condition? Main condition is to make sure the elements of the array are unique. Are unique, because that is the first condition, right? If we see the question, so that is the first condition, all elements in the nums must be equal, or sorry, unique. So that is the first thing. So if there is an array given to us, we first need to remove all the duplicates, and then we need to get something like this, which is unique. All the elements are unique, all elements are unique. So we need to get something like this. And after we get this, then we need to go with our logic. So what is the logic? Considering every element to be the minimum possible and trying to get the maximum possible element for that particular element. And to the right of all those things, we need to change. And as we go, we need to even change the left side of these things. So that is how you'll be approaching this problem. So let us go to the code now. So first, int n equal to nums.size and answer equal to n. So that is the worst case possible, where you need to change all the numbers, where you need to do all the change all the numbers. For example, if I consider something like the array to be 1, 10, 30 and 40, so either of them I need to change some of these things. I need to do all the changes, like I need to change 1, I need to change 10, I need to change 30, I need to change 40 to some other numbers, right? So there are things like situation like this. So that is the reason we are going with the worst case possible, that is answer equal to n. So and then we are taking a set S and we are trying to insert all the numbers into the set, because set gives us the ordered, like in the particular like increasing order, as well as all the elements of this set would be unique. And we have taken the vector unique elements, all right, unique elements, which actually takes up the elements of the set, set elements. Okay, so we'll be taking the elements of the sets and putting into the unique element. And now int size equal to unique elements dot size. So that is the size we'll need to work out. So we have stringed the array, like we have removed all the duplicates, and we have got an array where all the elements are unique. All right. So what are we trying to do? For int start equal to 0, start less than size, start plus plus. So we are starting from the beginning of the array. Okay, so from the beginning of the, let us assume this is the unique elements array. Okay, unique elements array, and we have this example already, 1 2 3 5 6. So 1 2 3 5 6. So let us assume we are at this position. All right, we are at this position. So int in n index is equal to upper bound of unique elements dot begin plus start. So this tells us the range that we are looking at. So if we are looking at from here, if we are trying to make this as the minimum element, so then my range should be from this point to this point, right? From this point to this point. If I'm at this position, then my range must be from this point to this point. So that is how it is. So unique elements dot begin plus start till the end. So what am I trying to find? I'm trying to find plus n minus 1. This is what we needed, right? So if we are considering this element as the minimum element, then the maximum element that can be is plus n minus 1. So according to the question, so that's what we are trying to find. And minus unique elements dot begin gives the, like, this is the address, right? This is the address, unique elements dot begin. We'll be getting the index of that particular element. So for example, okay, let me just not erase this thing. Okay, so if I'm at this position, if I'm at this position 1, okay, if I'm at this position 1, so I'll be searching for 1 plus 5 minus 1, that is equal to 5, right? I'll be searching for 5. So minus, so my end index would be this, in this position. What is this? 0 1 2 3. So this would be the answer, like this would be the end index. So this would be the end index if in case I am at this position. Okay, if I am at this position, if my start is equal to 0, then 3 would be the end index, right? Because I'm looking for the element, so start, the difference between that element and the present start element is n minus 1. So my unique end index, okay, my end index, as it's an upper bound, okay, that's an important thing that I forgot to mention. It's an upper bound. So when you do upper bound, you get the element index of that element that is just greater than the element that you're looking out for. So when I'm at this position, when I'm at the present index, when I'm at, like, when the start is equal to 0, then the element is 1. So then the maximum element that I'm trying to find is max element is equal to 1 plus 5 minus 1, which is actually equal to 5. So, and because it's an upper bound, it will point out to this particular index, right? Because 6 is just greater than 5. 6 is just greater than 5. So my end index at this position would be 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. So it will be pointing to this particular integer because 6 is the element that is just greater than that thing that we are looking out for. So we are looking out for 5. So 6 is greater than 5. So end index would be equal to 4. And now answer is basically nothing but answer equal to minimum of answer comma n minus n index, that is 4, minus start, that is 0. All right. So what is n? That is all n is equal to 5. All right. So 5 minus 4 minus 0, that is equal to 1. So initially the answer was 5 because that is a size. So answer equal to minimum of 5 comma 1, which is equal to 1. All right. So what does this mean? Because n minus this, why are we doing that? Because these elements are already fine. These elements already satisfy the condition that we are trying to look for. All right. Only this element that is right to the 5, all the elements to the right side of the 5 do not satisfy. So this is the window that satisfies. Okay. Window that satisfies our required condition, that satisfies. And this is the part that does not satisfy. So that is the reason we have removed this window length. We remove the window length minus total length. This is the total length minus window length. Okay, window length. And this is basically nothing but the end position minus end minus start. That's it. So that is what we are trying to do, and this gives us the number of operations. Number of operations is basically total length minus window length. So window length is basically the window that is actually satisfying the condition, right? So that's how we need to do, and very first iteration will get the answer to be 1, and that would be the minimum. As you proceed further, as we have dry run this example, so 1 2 3 5 6, case 1, case 2, case 3, case 4, case 5, you'll be seeing that the answer is actually growing 1 1 2 3 4 because we have kept the minimum. We'll always be having this as the answer. So I hope you people understood how are we trying to do. We are trying to find that large element possible for each and every particular element and removing and trying to modify other elements. So that would indicate the number of operations if we consider a particular element to be a minimum element. So, and we need the minimum operations needed. So for each and every element, we'll be checking how many operations do we actually need. If in case we are considering one as the, so let me erase this. So if in case we are considering 1 as the minimum element, if we are considering 1 as the minimum element, the maximum element that it can go up, it can get us 5, right? So all the other elements must be changed. So all the other elements from this range after 5 must be changed. If we consider 2 as the minimum element, so 6 would be the maximum element. So all the elements to the left of 2 and right of 6, right? Right of 6 and left of 2 must be changed. And if 3, then same is the case. 5, same is the case. 6 is same as the case. So we are trying to work on each and every particular element and try to get an idea. So this is how we do it. So it's a hard question, but still the logic remains pretty simple. It's just like how are we trying to approach, how are we using the things, because order is not actually needed. So we just need to we can sort the array and we can just work on it. So what is the time complexity? So let us analyze the time complexity here. Time complexity. So we are sorting the array, right? So we are sorting the array and that takes O of n log n. And what are we trying to do? We are doing the binary search on everything, right? We are trying to do the binary search upper bound as we discussed in the last video. So we are doing the binary search on everything. So, and that on every element. So again, n log n. So it's basically O of n log n. And what is the space complexity? Space complexity, we are not taking anything. We are just trying to we have taken a space, like we have taken a certain vector. So space complexity like O of n, you can even assume it to be O of n. All right, so we have taken a vector and set, so O of n. So that's it. This is how we can solve this problem very easily. So it's all about the approach. How are we trying to write that approach? Fine. It's just that we are trying to work on each and every element, get a conclusion about number of operations needed if that particular element is considered as the minimum most element. So, and we need the minimum number of operations. So we need to choose that element as the minimum element such that the minimum operation, such that the number of operations that we are that we need to do will be minimized. All right, so that is the funda and that is the approach here. I hope you people understood the question. You can even submit the code. The codes in all the languages, C++, Java, Python, I have submitted like I have uploaded them in the GitHub repo, and the repo link is in the description below. Please check it out, and thank you for watching. Stay tuned.